find the eigenvectors, once we know our eigenvalues, it's actually not so bad. So we're looking to solve AV equals lambda V, where V is not equal to 0. We know all lambdas, so that A minus lambda IV is equal to 0 has a non-zero solution. This solution is going to be our eigenvector. The solutions are going to be eigenvectors with which correspond to the eigenvalue lambda. So in order to find them, we're just going to solve this matrix equation. So we're going to take our eigenvalue lambda, we're going to compute A minus lambda I, and then we're going to use row reduction to solve A minus lambda IV equals 0 for my eigenvectors V. Let's take a look at an example. Okay, so we're going to go back to this the last example that we looked at. We found our eigenvalues there. What we're going to do in this example is we're going to find the eigenvector find all eigenvectors corresponding to the eigenvalue lambda equals 3. Our first step is to compute A minus 3i, or in this case it's C minus 3i. So what does this look like? C minus 3i is 1 minus 3, negative 2, negative 2, 1 minus 3. I'm just subtracting 3 from all the diagonal elements. And I get negative 2, negative 2, negative 2, negative 2. All right, notice this isn't invertible. If you got something invertible, you would have made a mistake earlier. So if you ever get something that's invertible, go back and check your earlier work. Something went wrong. Okay, next we're going to use row reduction to solve A minus lambda I times V equals 0. So we don't really need to, but I'm going to put in my augment of 0. So I have negative 2, negative 2, negative 2, negative 2, 0, 0. I'm going to pause and let you row reduce for a minute. Okay, so I end up with the following reduced row echelon form. And when I go to write down my solutions, if I have variables x and y, I get that x plus y equals 0. If I solve this, I get that x is equal to negative y. So I'm just rewriting my pivot variable in terms of my free variable. Okay, and my solutions V are going to have this form xy, where x is equal to negative y. So I get negative y, y, or another way of writing this is I have just a multiple of the vector negative 1, 1 for y any number. Okay. All right, so my eigenvalues, my eigenvectors for lambda equals 3 all have this form. They're all multiples of negative 1, 1. And it is easy for us to check whether or not we've successfully found eigenvectors. You can always multiply C times negative 1, 1, and you'll see you get negative 3, 3. So indeed, we have an eigenvector with eigenvalue of 3.